Okay, so we're talking about graphs of rational functions. So rational functions is probably the toughest part of this test. There is more than one part. The part we learned in 2.3 was different. That was just about increasing, decreasing, maxes, mins, that kind of stuff. But this rational stuff is harder. Here is a rational function. It's on the board. The blue dotted lines are its horizontals and verticals. So let's just walk through this quick and see if you could tell me, first of all, what's the parent of this whole thing? 1 over x. And what's this one that's on the board? Would you please, on your paper, write me this one. It's not 1 over x. It's more than that because it's been moved. Write me the equation for the one that's graphed on the board. I know you're looking like you're concentrating everything, but you get the paper out. Come on. You're obviously not going to take notes into your social studies book or whatever that is. All right. There'll be some time at the end where I won't mind if you're studying your whatever that is. I need you with me now. Okay, so to start with here, it's moved to the left 4 spaces. Did you put plus 4 down there? Good. That's in the inside there where it's left-right stuff. On the outside, it is an up-down thing, and it's up 1, and so I go plus 1 out there. All right. Are there any holes on this graph? You would be able to tell because it would be an empty spot. It would be like a circle with an empty spot, like that. And there aren't any holes in this graph. All right, we'll talk more about holes soon. Hey, the horizontal asymptotes, those are the horizontal asymptotes, the y things, remember? Those are the y equals things. It's really easy to get those goobered up, and you put the x things in where the y's are supposed to be, and you get it wrong. So remember, horizontals are the horizontals. The horizontal ones are, let's see, is this horizontal? This one right here? So that's y equals what? 1. And if I'm just looking at the graph for the verticals, vertical is like leaping up and down, your vertical leap. That's the spot, and that's an x. See, the v grows to be an x. X equals -4. The x-intercepts, it's just where is it touching x? Right there. And that's -5. And if I was doing an x-intercept, I really should say that y is 0, so I'd put it like that. The y-intercept is where x is 0, so I put 0, comma, right? And then what's the y-intercept? Well, it looks like it's about, what do you guys say, 1.2, something like that? 1.4, I don't know, 1.2, whatever. 1.257, okay, excellent. You got good eyes. Write 4 limits for it. Could you do that? Could you? All right, well, maybe limits is one of your weaker things. The limits to write for this are either you write the limit for way over there, and how does every limit start? Would you please write on your paper, even if I didn't tell you what part I wanted, you'd always start with the same thing. Limit. Lim. Oh, what comes next? As x, and I guess it doesn't really matter what order you write them in, but this is where they go. Approaches, and then we don't know what it approaches. It depends on what I want. If I want the left end, what would it approach? If I want the left end that's way down there, x would be approaching -infinity. If I want the right end, which would be way down there, x would be approaching infinity. And if I wanted the spot where I was approaching this line here in the middle of things, that's where x is approaching -4. But I can approach that from both sides. All right, so there's 4 limits you could write for this. I'd like you to write me one of the limits that's an end limit, like way out to the right or way to the left, and write me one of those limits that's one of the middle limits, the kind where it's approaching -4. If you don't understand what I mean, then you should be the one who copies what I write down exactly, because you don't understand limits and you're about to get 2 out of your 4 R3s wrong, I'd say, I'm guessing. There's a lot of limit stuff on there. Because limits is coming up in calculus, and it'll be really important to know in calc. So they want us to pound on it in pre-calc. So, all right, so if you chose to do the way right side, that would be as x approaches infinity. Way over there, what would the y be? 1. It's getting closer and closer to this line right here, which is the y would be 1. Okay? Next one. limit. I'm going to just erase this one and write the next one. Limit as x approaches negative infinity. Well, if I go way this way, y is going to be what? 1 again. Then, if I do one of those interior ones, that's the limit as I'm approaching this line here. The limit as I'm approaching negative 4. From which side? Well, if you start on this side, you're approaching it from the negatives. And that would be, well, if I was coming from this side over here, I'd get sucked down into that vortex, and I'd end up at negative infinity. If I do the other one, that's where I'm approaching negative 4 from the positives. That would mean I was coming from over here. I'm going this way. And where am I going to end up? I kind of end up going up this way, and I end up at positive infinity. Okay? Any questions about that? Yes? No. But if you have a regular equation, you can make the graph, and then you can write the limits. Sure, you may. Hold on just a second. So we've talked about pretty much the main things that you need to know. Now we need to get into some, like the nitty-gritty, tougher kind. What happens if they ask you to graph it? Okay, if it was already graphed, it was pretty easy. It's if they ask you to graph it. All right. Well, remember, if you are asked to graph something, it's always comes down to an XY chart. If I had this, right off the bat, I can see that those cancel. Do you remember what that creates? A hole. So in the graph, wherever x is negative 2, if the graph was like going like this and x was negative 2, there'd be an empty spot right there where I follow up from where x was negative 2. Be an empty spot there. Okay, and it makes the problem simpler because you no longer have to deal with it. It's like it's gone. So if I'm going to graph this thing, I need to now be able to handle making an XY chart. Just a quick reminder on making one. All you need to do is pick any number you want for x. You plug it in. So I'm going to ask you to plug in a couple numbers. Why don't you plug in x is 5, and why don't you plug in x is 10? And tell me what y you get. Nope, sorry, that's just messy. All right, so if you put in a 5, you would have a 5 here and a 5 here, and wait a minute, I have a 0 on top. What's 0 divided by anything? 0. The only exception is 0 divided by 0, which is actually undefined. But anyway, the 10, when I put a 10 in here, 10 minus 5 is 5 over 10 plus 7 is 17. 5/17 is the answer. Raise your hand if you had that one right. Okay, good. So now you've got 2 of your points. One of them is special. What's that one? What's this one called? The x-intercept. The x-intercept is where y is 0. So I stumbled upon the x-intercept in doing that. All right. And if I was graphing this, wouldn't it be kind of helpful to know the verticals and the horizontals? Like if I knew there was a line going like this, it would help me a lot. Or a line going like this. All right. So, given an equation, here are the other little pieces that are really going to help you. I would encourage you to take notes unless you totally know each part by heart. If you already know that thing, then don't copy that thing down. But take notes on the parts that you aren't good at. You're expected to be able to find holes. What kind of asymptote is that? That's supposed to be an H. Why is it sort of a funny looking H? Because it's an upside down Y. And why is it an upside down Y? Because those are Y things. Those are Y equals things. The V, the vertical asymptotes, they come from the denominator. V is sort of like, can grow into like the X things because those are X equals things. The x-intercepts are where y is 0 and the denominator cancels. The y-intercept is where x is 0. You can sketch it using an XY chart to fill in the gaps. And you can write 4 different kinds of limits. The limits where you're going way to the right, way to the left, the limits where you're going towards the middle. And they always start the same way. Okay, so there's the kind of like the power part where this is all the stuff you're supposed to know. So if in 2 minutes when I put the problem up you say, I don't know how to do that part, then I'm going to ask you, what did you write down? Because if you already know it, you won't have that problem. But if you don't know in 2 minutes how to use any of these, then you should have written them down. All right, now I'm going to give you an equation. I'm going to leave them up here. And I'm going to give you an equation. I want you to do each of these things. I want you to find holes, if it has any. Find horizontal asymptotes. Find the verticals, etc. All right. We're going to do this one. X plus 2, x minus 3. X plus 2, x minus 1, x minus 6. Oopie. Make sure I copied that right. Yep, there we go. Okay, so if this is the problem, you should be able to find me the hole, or holes, horizontal asymptotes, vertical asymptotes, x-intercepts, y-intercepts. You should be able to sketch it. And you should be able to write 4 different limits for it. In this case, to save you time, just write me one of the 4 limits. One of the 4 limits. Okay, holes. This part cancels, and it makes it way easier, because from that part on, you don't have to worry about those. You won't use them for any other part. So if you were using those for all the other parts, you're probably doing it wrong. And the hole there is because x equals negative 2 would cause the top, negative 2, would cause the top and the bottom part to be 0. And when that happens, you've got a hole. All right. Now, I really should put this hole should really be an x and a y. The x is negative 2, comma, the y is somewhere. Well, I'm not going to really know until I see the graph. You know what I mean? I don't know how high this thing goes up, but I know that it's a hole at a spot. This is not a line. See, x equals 2 is a line. So I should really write the hole not as x equals negative 2, but negative 2 comma something, and I don't know exactly where it is till I see the graph. Now, I could just take the x number, negative 2, and stick it in and figure out the hole. If I stick in the negative 2 here, and here, and here, I can figure out where that would be. Okay, but that's beyond the scope of what I need to do right this second. All right, the bob, sob, bot. What is this thing? Bigger on bottom, bigger on top, same on both. What is it? Bigger on bottom. And if it's bigger on bottom, it is what? To bob, it's y equals 0. Raise your hand if you had that. Good. So then if I graph this thing, I'm going to start to graph it here. If it's y equals 0, I have a line right here. That's an asymptote line at y equals 0. Okay. The vertical asymptotes, those come from the denominator. It looks like 1 and 6 would make this, x equals 1 and x equals 6, would make this thing crash, and so therefore those are my vertical asymptotes. Next thing, x-intercepts, where y is 0 and the denominator cancels. If I set this equal to 0, then all I care about is the top, because if the top is 0, then I don't care what's on the bottom. 0 divided by anything is 0. So that would be at x equals 3. And so x equals 3 is where the x-intercept is. So I'm going to go over here to 3 and put a dot. And that's one of those things that should be messing with your head because it's right on top of an asymptote line. And in the past, you weren't able to do that. Okay, next thing, the y-intercept is where x is 0. If I go back to my original here, clean this up a little bit, I just made my graph disappear. Great. But I'm going to stick in here. I'm going to go to this other one because it's a lot cleaner. 1, 6, 0. What was our x-intercept again? It's where the top here is 3, so it's right there. And now, we were working on the y-intercept where x is 0. Okay, if I stick in a 0 now, here, here, and here, I'll start my xy chart because I'm going to need one anyway. And if x is 0, I have negative 3 over 0 minus 1 is negative 1 times negative 6 is positive 6, which is equal to negative 1/2. So 0 comma negative 1/2 over 0 down 1/2. It's right there. Now, just from that point right there, I know that these lines always gravitate towards the asymptote lines. So now I know it's going to go like that. If I wanted to be absolutely sure, I could make my XY chart and like test. Let's see what I get at x is like 1/2. If I stick in x as 1/2, I'll see like where it should be down there. And if I have 1/2 in here and 1/2 in here and 1/2 in here, I'd have negative 2.5. So I'm sticking in 1/2. I'd have negative 2.5 on top over 1/2 minus 1 is this negative 1/2 and negative 5.5. So positive 1/2 of 5.5, which would be 2.25. And so that's basically about the same thing. It's about negative 1, and therefore, look at that. It was supposed to be about negative 1, and it was right there. So here is my graph starting to form. This one, I think, ends up going like this. And yes, they can cross asymptote lines in these problems. How would I know for sure? I could stick in more points. This is the part where it gets really tedious. If I want to stick in like 5, if I stick in a 5 here, I got to go back, clean this off, stick in a 5. Remember, I can cancel off the root and stick in a 5 now. 5 minus 3 would be 2 over 5 minus 1 is 4. 5 minus 6, negative 1. It's negative 4. 2 over negative 4, which would be negative 1/2. 5 goes with negative 1/2. Okay, I guess it's not down as far as I said it was going to be, but it's headed down. So I guess it went more like that. And then this, I'd have to graph it to see for sure if it was like tight or loose. But if your graph was headed the right direction, I'd be giving you credit. You wouldn't have to be exactly on top of where all the right points are. So in other words, this red one and this green one here, they're pretty much the same thing. Either way would be okay. It shows that it's going down versus going up. So all I'm saying is if your sketch, one kid's looks like this, another kid's looks like this. They all both knew it went through that point. And the other kid like made it like more like this. Pretty much the same thing. It's okay if one's tighter or one's looser. They're both heading towards the asymptote lines, which is what they should be doing, and they're both going through the point that they know worked. So I'm not going to be super strict about exactly where your curve wasn't tight enough. Yes?
How would you add in the hole?
All right, let's say that there was a hole at this spot right here at like 3 or something. Just put an empty spot on the line. That's it. So let's go back to this one. Where should there be a hole in this one? At negative 2. So right here empty spot. That is really easy to forget too. I remember doing that a lot because you got this magnificent graph and then they're missing the hole. Stinks. Okay. Let's see here. This is the only thing different about this one, and because these take a long time, I don't want to put you through a whole nother one. I want to like just do the part of it that is like that you need to practice. Anything that you think you need to practice. But the very first thing is these look different. This looks different than all the other ones because it isn't what? Factored. All you have to do is factor it. And that'll look just like the other ones we just did. What's the top one factor to? X and X, plus and plus, 2 and 1. On the bottom one, X and X, plus and minus, -3, +1, I think. First works outside and inside, makes -2x. Last makes -3. Yep, it works. And then that makes a hole. And then I'm off and running. Now I can do all the rest of the stuff. Okay, so don't forget to factor it. Now, are there any of these parts that you want me to talk more about? Like you don't really understand one of the kinds? Yes? Yep. Yep. And you'd be expected to do something over there too. So you'd have to stick in like 7. See how 7 is I don't know where it is. So I'd stick in a 7. 7 minus 3. So here's 7 on my chart. 7 minus 3 is 4. Over 7 minus 1 is 6. 7 minus 6 is 1. 6 times 1 is 6. 4 6, which is 2/3. So 7 goes with 2/3, which is like right there. And then I'd need to, I'm guessing it's going to go like this. See where I'm kind of headed with that? Yes?
Well, asymptotes always come from the direction, like, it goes down after 5 there, will always, like, come from the top and come down to 7 from the top.
Nope. This could be going like this. You have to test points to find out where it's coming from. Yes? Yes. You can do it, but we haven't even learned how to do that, so don't worry about that. Any others? Okay. Then there's some special cases that I need to warn you about. When you're doing this problem, first thing you do is factor the top, right? You'll end up with x plus 6, x plus, no, that won't work, will it? Will that factor? I don't think it would factor. Let's make this a minus 5. Oh wait, no, 2 and 3, it would factor. You're right, 2 times 3, it'll work. Sorry. Okay, x plus 2, x plus 3. Okay, and then the bottom, x squared plus 3. Well, first of all, you cannot cancel those. Those are different. X plus 3 and x squared plus 3 are different. And you can't break x squared plus 3 up. Now, here's the weird thing. You know how we've always been able to find the verticals from looking at the denominator? Do you see how the denominator can't be made to be 0? There's no way to make that 0. Because I can't ever get this part to be -3. You know what I mean? So this kind, you can't make the denominator 0. So it has none when it comes to vertical asymptotes. Okay, normally it's just find whatever makes the bottom 0. Vertical goes with denominators. All right, horizontal. On this kind, is it bigger on bottom, bigger on top, or same on both? Bigger on the bottom, so it's y equals 0. That's really easy. What's the thing that, on this kind, that kind of circled in blue here? Something special about this that's different than all the other ones. There's no x on the top. Which part, which kind of thing, 1, 2, 3, 4, 5, 6, or 7, uses the top? Remember the kind where the denominator doesn't even matter? That's when you set this equal to 0, which is the x-intercepts. So this is supposed to be, when can I make this equal 0? I can't. And that means whenever you can't, then you don't have any. Is it possible you could have no x-intercepts? Yeah, it is possible. Okay, so then, in this case, you'd say none for this problem. You can't make this top 0. So if y is 0, you can't figure out any x that would make that happen. So there are none. No x-intercepts. Okay, so those are a couple special cases to watch out for. And I want to give you a fair amount of time, which you do have. You got like 15, 20 minutes now. And your book assignment was not super hard, not super easy. It's kind of longish. That's why I said you didn't have to have it done until Monday. So it's right here. It's the page 245, 5 and 6 and 11 through 22, 24 through 28 evens, 38 through 44 evens. Remember, I added one problem there. It used to be to 42. We're doing 52. We are skipping 62 and 64 to 66. Okay?